Okay, here we go, guys. Now, an Olympic standard sprinter was developed. An Olympic standard 100-meter sprinter was developed by mathematicians. The speed of the sprinter may be calculated by the following function, where t is time in seconds from the starting signal. Find the maximum speed of the sprinter. Maximum means slope equals 0. The slope of the function equals 0, i.e. the first derivative has to equal 0. Now, before I start this, I'm going to multiply this out, and you'll see why in a second. Makes the whole thing easy. 11.7 minus 11.7 e to the minus 0.8 t, and then 0.03, and what else is there? The minus 0.03 e to the 0.03 t. Everybody cool with that? Now, what happens when I differentiate this once? What happens? 11.7 turns into 0. The 0.03 turns into 0. So I'm essentially only differentiating this one and this one, which is good news for me. Ready? So what do we learn about E again? Its power remains unchanged, yeah. A regular number just goes straight through. Differentiate the power, and what do I get? Once I differentiate this power, minus 0.08. What's 0.8 times 11.7? 9.36. Happy days. I saw some epic battles in this one, but they weren't really necessary. You know? Now, same deal here. Minus 0.03 e to the 0.3 t, because when you differentiate it, it turns back into itself. We've got to differentiate the power, which is an extra 0.3. And what's 0.3 multiplied by 0.03? Minus 0.09 e to the 0.3 t. Is that okay? You cool? All right. Now, here we go. Go with that? Okay. Now, what I'm going to do next, guys, is the following. That's my first derivative, yeah? And what did I say I have to put the first derivative equal to? I have to put it equal to 0, which means the following. 9.36 e to the minus 0.8 t is actually the same as 0.09 e to the 0.3 t. I'm going to put the e's together. So I'm going to divide by this red one here. See that red one? I'm going to divide by it and put it underneath that one. So e to the 0.3 t underneath e to the minus 0.8 t. Cool with that? And I'm going to put the 9.36 and the 0.09 underneath each other as well. What can I do with these two powers? What's x7 divided by x2? What do you think the answer to that is? x5. What's x7 and then x minus 2 on the bottom? Because you add them, don't you? And I'm going to end up adding the two of these to get e to the 1.1 t. Now I'm in business. Because what is the thing I have to do next? ln both sides. And then I'm going to get 1.1 t, because you move the power to the front using the power rule of logs. And it's going to be 1.1 t is the same as whatever ln, what's it, 9.36 divided by 0.09 is. Okay, I'm going to load that into the good old calculator. Nope, that's not where my calculator is. Here it is. Now, it's going walkies on me again. Oh, it's doing that thing again. Love it. All right. There we go. Yes. Now, here we go. Log, where's that ln on this, guys? Anybody know? Shift log. Getting used to this. 9.36 divided by 0.09. Oh, sorry, just 1 0. Okay. Whatever that answer is, I'm going to have to divide it by 1.1, haven't I? 4.22? No. Something went wrong. 1.1. Okay, just give me 1 sec. Did I enter the LN wrong? What is 936? 9.36 divided by 0.09? 104. It wants 1040 here. Did I forget an extra 0? 2 zeros. That's what I did wrong. I was right the first time. It's 2 zeros and a 9. So I made a mistake here. It's 2 zeros and a 9. So for anybody at home. So it's if we can press OK here. All right, go back up here and change to 0.009. There we go. 6.94, and then divide that by 1.1. And then press execute. Yeah, 6.31. That was the answer. Yeah, 6.31. Got it. Now, next one, guys. Find an expression for the distance traveled. So, our current, do you remember the differentiation? When you have distance and you differentiate it, you get speed. When you have speed and you differentiate it, you get acceleration. We're starting off on speed. Yeah. Oh, need to find the speed. Yeah, thanks for that. Sorry, guys. 6.31 is the time. So you're going to have to get the time and sub it back into the speed function at the start. So you're going to have to actually sub it back in at this stage here. So see this formula here? You're going to have to get the 6.31 and you're going to sub it in here. Actually, this was pretty hard as well. And then another 6.31 here. And then when you multiply all that out, you'll get 11.46. Does anybody get 11.46? Yeah? Well done. All right, guys. I think I'll leave the part 2 of this now because that was quite tough.